Good morning and welcome. We have started the topic number 5, gaseous state. And in this topic we we have studied up to the density of the substance. We have also studied Boyle's law, Charles' law, combined gas law, ideal gas law. All these things we have studied in my previous lectures. Today we are going to solve, or we are going to understand what is molecular weight and how molecular weight is determined. Before that, I want to revise some points which we have studied in previous periods. So first, I want to explain density. Density is equal to mass divided by volume. Mass divided by volume. The same relation can be written D is equal to m upon v. When mass is expressed in gram and volume in liter, then the density is expressed in gram per liter. The unit of density is gram per liter. Density of the gas or density of the volatile liquid is determined by density is determined like this. The molecular weight of volatile substance is determined from the density. Density is directly related, is proportional to molecular weight. So this density is used to determine molecular weight. Volatile liquid means the liquids which gets converted into vapor state easily. That means the liquids having lower boiling points are volatile liquids. We are going to study how to determine molecular weight of volatile liquid. Before that, I want to explain, or I want to derive one simple formula. You know that P into phi is equal to nRT. This is ideal gas equation. In this equation, P is the pressure of the gas, phi is the volume of the gas, N is number of moles, R is gas constant, and T is absolute temperature in Kelvin scale. So here I am going to tell you one more formula. N is equal to, N means number of moles. Mass of the substance, small m, divided by mm, molecular weight of the substance. So here N is equal to I substitute m upon mm. Therefore, the equation becomes PV is equal to m upon mm into RT. For this n, I substituted this value. Now, this denominator I take on left hand side. Therefore, the equation is P into mm is equal to. Now, take this phi. So this is denominator. Take denominator on left hand side. Take this numerator on right hand side. Therefore, m upon phi into RT. But you know that m upon phi is equal to density. Look here. Mass divided by volume. So the equation becomes Pmm is equal to dRT. So this is ideal gas equation, and this is one more relation. By using these relations or these equations are used to determine molecular weight or molar mass of volatile substance. So, we are going to solve some numericals based on these formulae. So, remember these formulae, these are very important. The topic is problem-based topic. Problems are important. You have to solve any type of problem. Very simple problems are there. So first, I want to explain how molecular weight is determined. Dumas method. Dumas is the name of scientist. Dumas method is used to determine the molecular weight of substance which can be vaporized without decomposition, which can be vaporized without decomposing. So, petrol, ether, alcohol are the compounds having low boiling points. They are volatile liquids. Their molecular weight is determined by this experiment and these equations. Now look here, the given quantity of liquid or volatile substance is taken in 200 ml flask. So the volume is 200 ml. But you see, we are here using volume in liter. Therefore, this 200 ml I want to convert into liter. I divide by 1000. Cancel these two zeros with these two zeros. 2 upon 10 is equal to 0.2 liter. So this is 200 ml flask in which volatile substance, given volatile substance is taken, and this 200 ml flask is submerged into boiling water. This is a glass beaker. This is a glass beaker containing boiling water. Here is below there is furnace to heat flask. Here is the stand on left hand side. The diagram, very beautiful diagram is given in your textbook. You see that diagram. Then this is the thermometer to record the temperature. This is the thermometer to record the temperature. The temperature of water, I explain after some time. You look here, when this flask is heated in water, the volatile liquid is converted into vapor state. Because its boiling point is less than 100. When it is converted into vapor state, the flask is completely filled with vapor. The flask is completely filled with vapor. Now some vapors escapes. When all the substance is converted into vapor, the flask is cooled. After cooling, the vapors gets condensed. That means the vapor again converted into liquid state. Then the temperature at that time is 99 degrees centigrade. Look here, this is temperature in degrees Celsius or degrees centigrade. But in this equation, temperature is Kelvin. Temperature is in Kelvin scale. Therefore, add plus 273, that is equal to 372 Kelvin. The barometric pressure is measured. The pressure is measured by using barometer. The barometric pressure is found to be 768. I write here P is equal to 768 atmosphere. 768 mmHg. That is equal to 733 mmHg. 733 mmHg. Temperature is 372 Kelvin. We want this pressure in atmosphere. We convert this pressure into atmosphere after few minutes. So these are the values which are supplied. When the flask is cooled, the vapor gets condensed into liquid. Then the mass of this flask is noted. The weight of the flask is taken, and after the experiment, the mass of empty flask is taken. From their difference, the weight of the liquid or mass of the liquid is determined, and that is equal to 0. Mass is equal to 0.970. So these are the datas given and some are obtained from experiment. By using this relation and this relation, we are going to find out molecular mass of the substance. I think it will be clear. Now I remove this diagram. I clean the board. So I write here P is equal to 733 mm Hg. Phi is equal to 0.2 liter. Temperature 372 Kelvin. Mass of the substance is obtained from experiment, that is equal to 0.970 gram. Now we have two relations. One is PV is equal to nRT. Another is PMM is equal to DRT. D is equal to mass divided by volume. Number of moles, N is equal to M upon mm. Mass of the substance divided by molar mass of the substance or molecular weight. In problem, we have asked to find out molecular weight. Nm is equal to question mark. Whenever you are going to solve any problem, first read the problem carefully. Write down the given data. And what is given and what is we are going to find out. Then you will recall the formula which to be used. PV is equal to nRT, PMM is equal to DRT. You know how density is determined, how number of moles are determined. If it is clear, I am going to solve the problem. PV is equal to nRT. Solve this problem for N. N is equal to P into phi divided by RT. Substitute the values, that is equal to P is given in atmosphere. We want to convert, P is given in terms of height of mercury. We want to convert into atmosphere. So look here, 760 mm Hg is equal to 1 atmosphere, and therefore 733 mmHg is equal to how much atmosphere? We have to convert this. So that is equal to cross multiplication 1 into 733 divided by 760 that is equal to. The answer is, you solve it by using log table, by using calculator. The answer is 0.964 atmosphere. Substitute the value of P in this equation. 0.964 into volume 0.2 divided by R. R is gas constant. I here use R is equal to 0.0821. R is constant and its value is known. I write this value into temperature 372 Kelvin. 372 Kelvin. Before making calculations, check the values which we have taken and which we have substituted are correct or not. If there is mistake, the answer will be definitely wrong. I check the values. I think it is clear. It is correct. Therefore, find out these values or solve this equation by using calculator. The answer is 0.000631. Number of moles. Here I write the unit mole. So we have calculated number of moles. Now mass per mole. I write mass per mole or molar mass, that is equal to gram vapor divided by mole vapor m upon mm. So that is equal to the weight of the mass of the substance 0.970 divided by mole vapor 0.00631. The answer is 154 gram per mole. This is molecular mass. So by using Dumas method, how molecular weight is determined and calculated, I have explained this. If it is not clear, see the video once again, then it will be cleared. Now, the same molecular mass is also determined by using the relation. This is molar mass. The same answer can be obtained by using the relation is equal to DRT is equal to DRT. Molecular mass or molar mass is equal to DRT upon P. DRT upon P. But we don't know the value of D. The value of D. Calculate D by using the relation M upon V. M upon V. That is equal to mass 0.970 divided by divided by volume 0.2, that is equal to. Simple division is there. You know simple mathematics. You can calculate orally this value and it is found to be 4.85 gram per liter. This is the density. So density I have calculated. So that is equal to 4.85 into gas constant R 0.0821 into temperature 372 divided by pressure 0.964. Check whether the values written are correct or not. I think they are correct. And the answer is, same answer, you will get 154 atom mass unit. Molecular mass is expressed in this unit, atom mass unit, molecular weight. So by using Dumas method, I explained how to determine molecular weight of the substance. So if it is clear, we shall solve one more problem. So first, I clean the board. We are going to solve exercise 5.8, which is given in your textbook. I write the problem. A sample of gaseous substance at 25 degrees centigrade and 0.862 atmosphere has a density of 2.26 gram per liter. What is molecular weight? What is molecular weight? This is the exercise given in your textbook. So I write here solution. I write solution. So I told you, before solving any problem, read the problem carefully. Write the given data, whatever is given and whatever is asked to find. You write it. If there is interconversion of units is required, interconvert the units, write the formula and substitute the values and get the answer. So here I write a sample of gaseous substance at 25 degrees centigrade. T is equal to 25. I want this temperature in Kelvin scale plus 273. That is equal to 5 plus 3, 8, 7 plus 2, 9, 298 Kelvin. This is the temperature. Pressure is given, P is equal to 0.862 atmosphere. Density is given, density D is equal to 2.26 gram per liter. What is molecular weight? mm, capital M. This is asked. Now, in previous example, pressure is given in terms of height of mercury column. Therefore, we have converted that mmHg into atmosphere. Here directly pressure is given in atmosphere. Therefore, there is no need of conversion. I write the formula. We have two formulas. PV is equal to nRT and PMM is equal to DRT. Apart from this, we know that density is equal to mass upon volume, number of moles, N is equal to mass in gram divided by molar mass in gram, mm. So by using these formulas, we are going to find out molar mass of this gaseous substance. So which formula will you use? Density is given, pressure is given, temperature is given, R gas constant is known. Therefore, you can find out molecular mass. So I use this relation mm is equal to d r t upon p, dRT upon p. So that is equal to, substitute D is equal to 2.26 into R 0.0821 into temperature 298 divided by P. Pressure is 0.862. That is equal to. The answer is 64.57. I have not made calculations. You do separately, or you make these calculations and find out the answer. That will be your answer. So I solved this problem by using this equation. Now I am going to solve the problem by using PV is equal to nRT. So here, solve the equation for n. N is equal to P into V upon RT. That is equal to, pressure is 0.862 into volume. The volume is not directly given, but here density is expressed in gram per liter. Therefore, I take 1 liter divided by R, gas constant 0.0821 into temperature 298. That is equal to, you make calculations. N is equal to 0.035 mole. We have calculated number of moles. We have to calculate molar mass. You know the relation N is equal to W upon M or M upon M. Therefore, capital M molecular mass is equal to small mass divided by N. Therefore, M is equal to mass of the substance 2.26, moles of the substance 0.035. That is equal to 64.57. So this is about molecular weight and its determination by molar mass. Today we are going to stop here. In next video we are going to learn stoichiometry problems involving gas volumes. Stoichiometry problems involving gas volumes. These are somewhat difficult problems we will solve in next video. Thanks for watching and listening carefully. Thank you so much. We will meet in next video. Okay. Dhanyawad. Have a great day.